everyone, let's see Java interview questions. What is JVM, JRE, and JDK? Let's see. JVM Java Virtual Machine is responsible for running the Java bytecode into a machine code for a specific operating system. JRE is a Java runtime environment, is a package which includes the JVM and other essential libraries to run Java programs. JDK is a toolkit for a developers, which includes the JRE, a compiler, and then it will allows the tools for building and then compiling and then debugging the Java applications code. Why we need means JVM ensures the Java program can run on any computer, making it run on any operating system, making it platform independent. Java runtime environment provides the tools and libraries for running the Java programs. Java Development Kit allows the developers to write code, compile, and debug the Java programs. How this works means if I write a Java program, helloworld.java, the JDK, the JDK compiles my code into a bytecode, a dot class file. When the program runs on someone's computer, the JRE provides the necessary tools and libraries. And then finally, JVM compiles the Java bytecode into a machine specific instruction so that a Java program can run on any operating system like Windows, Linux, or Mac. So this is the explanation for what and why and how of for JVM, JRE, and JDK. Let's see what is a class and object. Class is a blueprint that defines the properties and methods. An object is an instance of a class that represents the real world entities with actual data and values. Why we need means using with the help of class and objects, we can organize the code, we can make it reusable, and then object allows you to create a multiple instances of the same blueprint with unique data. Let's see the example for this. Let's have the example core class. It has the property speed and brand and a method called a drive method. So when I create an object for this, it will create an actual core for that. It's like building an actual core based on that blueprint. For a first object, object one, the brand named core brand named Toyota and its speed is 80 km per hour, and another core object brand named Hyundai and then its speed is 60 km per hour. So and if I have created an object, if I call the method drive method, so it will looks like a Toyota will drives 80 km per hour, and then that Hyundai car will drive for um, 60 km per hour. So for these properties, we have the same behavior, that is method drive method for these two properties, speed and brand. So class is a structure, and whether object is a specific structure, objects are the specific instance of that structure. So these are the class and objects. Let's see. Oops. Object oriented programming is a programming paradigm focused on objects and entities that combine the data and behavior. So it has the four key principles: encapsulation, inheritance, polymorphism, and abstraction. Encapsulation is like bundling the data and properties into a single unit. It restricts this direct access to the some part of the object by using the access modifiers like private, protected, and public. Why it is important means data hiding and security. By making the field private and exposing them through the public methods like getters and setters to prevent the unauthorized changes. For example, if we have a bank account class, there is a field named balance to store the account's money. If the balance field is public means anyone can directly change it. Even we can set a invalid value like a negative number starting, so the amount will be invalid. So to prevent this, we make the balance field as a private, so it cannot be accessed directly. Instead, we provide the public methods like deposit and withdraw to update it. So deposit method ensures only the positive amounts are added to the balance, and withdraw method checks if the amount is valid and within the available balance before detecting it. So another example is encapsulation groups related attributes and behaviors in one unit. For example, in a core class, attributes like a speed and fuel are combined with methods like start or stop. This mirrors how a real core works. So by controlling the access and bundling data with a behavior, encapsulation ensures the better data integrity and security. So this is explanation of the encapsulation. Let's see the inheritance. Inheritance allows a child class to inherit the common properties and methods from the parent class. So it promotes the code reusability. For example, we are building a vehicle system. So vehicle class will have the common properties like speed and then common method like start. So core class and bike class can inherit the same properties from the parent class. So we have the two patterns in inheritance, single inheritance and then hierarchical inheritance. If a one subclass inherit the one parent class means it is a single inheritance. Multiple subclass inherits from a superclass means it is a hierarchical inheritance. Let's see what is polymorphism. Polymorphism means many forms. It allows a single interface to behave differently depend on the object. So why it is important means it provides a flexibility and writing the reusable code and then maintainable. So how does it work means there is a compile time polymorphism and runtime polymorphism. Compile time polymorphism means it is decided at the method to be executed is determined during the compilation time. This is achieved through the method overloading, where multiple methods in the same class share the same name but differ in the number of types in their parameters. For example, a class calculator, it has the two add methods. One add method takes the two integers and adds them, and another add method takes the two double values and then adds them. So when the program runs, Java chooses which method to execute based on the arguments you pass. For example, if I call add of 3 comma 4 means the method for integers runs and returns the 7 as a output. So if I call the add method like by passing the 3.5 comma 4.2 as a double, so the method for doubles runs and then returns the output. So Java makes the decision during the compilation itself, which is why it is called a compile time polymorphism. Let's see the runtime polymorphism. So the method to be executed is determined at the runtime. So it is achieved through the method overriding. When a subclass provides its own implementation of a method defined in the parent class, is called a runtime polymorphism. So for example, we have a parent class called animal with the method sound. That means the animals makes a sound. So now a subclass dog overrides the sound method to print dog box. So when we create an object of the dog class but refer it using an animal reference, that is animal class. So the overridden method in dog is called at runtime. So here even though the reference is of type animal, the actual object is dog. So at runtime Java resolves this and calls the sound method of the dog class. So this is the difference between runtime and compile time polymorphism. Let's see the abstraction. So abstraction hides the complex implementation details of a system and only exposes the essential features to the user. So why it is needed means it simplifies software design by allowing user to focus on what object does rather than how it does it. For example, if you have a shape class, this class has an abstract method called draw. Different shapes like circle and rectangle inherit from the shape class and provide their specific implementations of draw method. So now a user you don't need to know how a circle or rectangle is drawn internally. So you just call a draw method on a shape object and the appropriate shape specific drawing happens behind the scenes. So this is the usage of abstraction. Let's see the static and final keywords. Static is used for class level members shared across all instances and it ensures the shared behavior or data. Final is used to create constants, prevent inheritance. So it ensures immutability or restricts the undesired changes. Let's see the Java collections. Java collection frameworks provides the classes and inheritance to manage data structures like list, sets, queues, and maps. So why it is needed means collections simplify the data management, making tasks like searching, sorting, and insertion efficient. So how it works means a list like array list allows duplicate elements. A set like hash set removes the duplicates, and then map like hash map stores the key value paths. Let's see the lambda function streams and generics. Lambda functions allows the functional style programming with concise syntax for anonymous functions. It reduces the boilerplate code. Streams means it simplifies the operations on collections like filtering and mapping. It allows the declarative programming and parallel processing. So generics provide type safety by allowing parameterized types and it prevents the runtime errors. So this is the explanation of lambda function, streams and generics.